Hello students, this is my 7th and last lecture on chapter 5, that is matter and magnetism. In this chapter, I am going to talk with you on hysteresis curve, permanent magnet and electromagnet. Now move to hysteresis curve. Hysteresis means lag behind. After the explanation, you will be able to understand why this curve is termed as hysteresis curve. This curve shown in image is drawn between magnetic field induction B and magnetization H for a ferromagnetic material. This curve indicates the complex nature of ferromagnetic material in respect of magnetic field induction and their relation with H, that is magnetization. Initially, let us consider a ferromagnetic material be unmagnetized, यानी उसमें magnetic field नहीं है, zero magnetic field. Now, we place that ferromagnetic material in a current carrying solenoid as a core. We insert that material inside a current carrying solenoid as a core, and then we increase the current in the solenoid from 0 as shown in this curve from 0. As we increase the current in solenoid, value of H increases, and when we reach beyond 200 ampere per meter, the magnetic field induction B becomes 1.5 Tesla, which is maximum value. After this one, if you increase the H, B, that is magnetic field induction, not increase. So this is called saturation value of magnetic field induction at any specific value of H. It is denoted by curve OA. Now, if we decrease the current in solenoid, on decreasing the current, H decreases. When we reach to 0 value of H, that is magnetic field induction, zero value of H means magnetization. At the zero magnetization, magnetic field induction is B, is at B. This point is, see this point B. It is non-zero quantity, which is more than 1 Tesla in the figure. So, at zero magnetization, magnetic field induction is non-zero, while it was 0 initially when H was 0, but now it is a non-zero. It has a magnitude more than 1 Tesla. So this value of magnetic field induction at H equals to 0 is called remanence or retentivity. Now, as this is the curve AB, now as shown in the image, we reverse the current in the magnetic field induction and increases as shown in curve B to C. At point C, magnetic field induction becomes 0, but at this point H is a non-zero because there is a reverse current. It is around H has the value around 100 ampere per meter, but magnetic field induction is 0. This value of H when magnetic field induction is 0 is called coercivity. Now if we further increase the current in reverse direction as shown in curve C2D, magnetic field induction reaches to its maximum value in reverse direction. If we further decrease the current in reverse direction D to E, we have again a value of B, that is magnetic field induction at 0 magnetization. Again it is indicated as remanence or retentivity. And further on reversing current and increasing the current in previous direction as shown in curve E to A, magnetic field induction reaches to its maximum value, that is saturation value. In this way, one cycle is completed. Now one very important thing is noticeable here. OA does not retrace its path when current is increasing from 0 to higher values so as to reach the maximum value of magnetic field induction, that is saturation state. As initially we were tracing the path O to A, after completing the cycle, during completion, we are not able to retrace the path. It means for a unique value of H, B is not unique. See this, B, for unique value of H, B has two values, this one and this one. So it means the value of H depends on previous history of the sample. See how it was magnetized depends on it. Value of B depends on previous history. It is not unique. This phenomena is called hysteresis. Now I think it will be clear to you. This behavior of hysteresis curve is very important for us to understand, because this behavior can be used to make a permanent magnet. We have learned there two terms, coercivity and remanence or retentivity. Those materials having high retentivity and high coercivity cannot be demagnetized easily by the stray fields or temperature fluctuation. They cannot be demagnetized. So those type of material can be used to make a permanent magnet, like steel, alnico, cobalt, etc. As like in this figure, this is the curve, that is hysteresis curve of large area. This curve is suitable for, because it has a high retentivity and high coercivity. This curve indicates that such type of material having large hysteresis area are suitable for permanent magnet. While for making temporary magnet or electromagnet, this curve should be small. Retentivity should be small and corrosivity should be small, so as to when those materials are removed away from the magnetic field, their entire magnetism may disappear. That's why it is very important to have low retentivity, high permeability and low corrosivity for the materials which are used inside a solenoid to make electromagnet. On placing soft iron rod inside the solenoid and passing current, its magnetic properties can be increased thousands of times. When we switch off the current in solenoid, the magnetism will be switched off and soft iron core having low retentivity will demagnetize. That's why electromagnets are used in electric bells, loudspeakers, etc. Thank you very much for listening. I think this entire chapter must be clearly understood by you.